volume of cones, real world problems. Okay. So the image below holds 192.4 cubic centimeters of ice cream and has a diameter of 7 centimeters. What is the height of the image? So similar to cylinders, real world problems, you're not always finding volume. This time I want to find height. So volume is 1/3 pi r squared times height for a cone. So I would like you to try this one before I show you how to do it, because it's not 100% different from how we were doing cylinders. The only difference is we have this 1/3 in there. So I pause the video, fill in what you know, see if you can find the height of the cone. So if I'm filling in what I know, my volume's 192.4. Okay, 1/3 pi. I gave you the diameter, which is all the way across here. The diameter is 7, so the radius is half of that. So 3.5 squared, and h is what we're solving for. So this is just an equation where we're solving for a variable. So I'm going to draw my brick wall. The longer way, if you're showing your steps, which is encouraged, is just to combine all of these numbers. Okay, right? These are all numbers that just need to be multiplied together. Oops. So again, I always put my fraction in parentheses. 1/3 times pi times 3.5 squared. All of those simplify to be 12.8 times height, just 192.4. So since this is being multiplied, the inverse is going to be to divide. So 192.4 divided by 12.8 tells me that the height is equal to approximately 15 centimeters. A Christmas tree has a volume of 201 cubic meters and a diameter of 8 meters. What is the height of the tree? So again, this problem you are finding the height. So go ahead and pause it and try it first, and then play to see the answer. So if I'm filling in what I know the volume is 201 cubic meters. I gave you diameter again, which is all the way across, is 8. So half of that is my radius, which is 4, and we are trying to find the height. So I'm going to simplify all of this by typing in 1/3 pi 4 squared. That gives me 16.8 divided by 16.8. So 11.96 rounded to the 10th actually rounds up to be 12 meters. So the tree is 12 meters tall. A party hat has a volume of 251 cubic centimeters and a height of 15 centimeters. What is the radius of a hat? Okay, so this one's a little different because we're finding the radius instead of height, but I still think you can try it first. Play through the video if you get a little stuck. So filling in what we know, the volume's 251. Radius is what we're solving for this time, and I know the height is 15. So again, I'm going to combine 1/3 pi and 15. They're all being multiplied, so I can combine that to just be one number. So 1/3 times pi times 15 gives me 15.7 r squared, right? My variable is squared because we're finding radius. So we still want to divide by that number we found, 15.7. Which gives me approximately 16. Now that's r squared. Remember, we want to find the radius. So to undo the fact that r was squared, we have to take the square root to cancel that out, which gives me the radius to be 4 centimeters. All right, the hut holds 94 cubic feet, has a height of 10 feet. To the nearest tenth, what is the diameter? So this is a little different because I'm asking you to find the diameter. And in the volume formula for a cone, is there a diameter for me to solve for? No, the volume of the cone uses the radius. But if I find the radius, I can then find the diameter. So before I can find the diameter, first I actually want to know, well, what is the radius? So just like in the last problem, first you have to find the radius, then find the diameter. So at this point, pause the video and try it on your own, then play through to see the answer. Volume's 94 cubic feet. We're finding radius first. My height is 10. Okay. So I'm going to combine my 1/3, my pi, and my 10. 1/3 times pi times 10 gives me 10.5. So 94 divided by 10.5 gives me approximately 9. Take the square root to get rid of r, or to get rid of the squared, to find r, which is 3 feet. So if the radius is 3 feet, the diameter then must be 6 feet. All right, last one. Why don't you pause this one and give it a try? Okay, candy corns have a diameter of 5 centimeters, height of 13 centimeters. How much candy does it hold? So we are actually finding the volume here. So 1/3 pi times my radius, right? I gave you diameter, so my radius is going to be 2.5 squared times my height. So 1/3 times pi times 2.5 squared times 13 gives me 85.1 cubic centimeters.